Okay, guys, so this is problem 19 from section, I think it was section 5.5. Okay, this is the only proof I want you to worry about doing. I'm going to do number 18 in class tomorrow. The other proof, number 23, is ridiculous, and we're not going to worry about trying to work through all those steps. Okay, I want you to work with the more basic ones that you're going to be seeing on your test. Okay, so 19 gives you this picture over on the side. It's saying that JL is congruent to LM. Okay, and I want to prove that KJ, which is right here, okay, KJ plus KL is greater than LM. Okay, now a couple things you should be noticing. LM is the same as JL. Okay, and if it's the same as JL, you know we can I'm thinking of the wrong word here. We can replace them with one another. We can substitute. Okay, which is going to be helpful to us as we go through this, because we also know that KJ plus KL has to be greater than JL, and that's by our triangle inequality theorem. Okay, so you're going to start out however you want with either one of those statements. Okay, so I know that KJ plus KL is going to be greater than JL, and that's by the triangle inequality theorem. Okay, I also know that JL is going to equal LM, and you do need to say it's equal because this is an inequality. We're not using congruency, we're using equality, and that's just by definition of congruence. So now that I have it as an equal sign, I'm going to replace it. So if J equals LM, then by substitution I can say that KJ plus KL is going to be greater than LM. I'm just replacing the JL with the LM, and that's by substitution, and that's it. That's this whole proof. Okay, so once again, triangle inequality theorem is what you're going to be using throughout these proofs. All right, so I have my triangle inequality theorem that I'm saying that JL is equal to LM, therefore I can replace one with the other. And because I know this by the triangle inequality theorem, I can replace the JL with the LM within the problem. And then I have my proof. Okay? Like I said, don't worry about this one. It's way more involved than it needs to be, and we're not gonna mess with it. Okay, I did want to do a couple problems from your section tonight, 5-6. I don't think I did a great job explaining this in class, so I want to make sure it makes more sense when I had a little bit more time to look at it. Okay, so looking at these two triangles, we know we're dealing with a side angle side inequality. Okay, so since I have two sides that are congruent, I'm looking at my included angle. And within my included angle, I know 57 is greater than 41. Therefore, the opposite side, 12, is going to be greater than the opposite side, 3x minus 6. Okay? Let me make sure I wrote that down right now that I'm looking at it. Can't tell if that's a subtraction sign. Yes, it is. Okay, so I'm going to solve my inequality. So I'm going to add 6. And I get 18 is greater than 3x. I'm going to divide by 3. And I have x is less than 6. Okay, now this is the problem. Because I know that x is less than 6, and I'm going to switch this around here, then I know that x can be 0. And we know that's not going to work. 3 times 0 minus 6 is going to give me a negative number, and my side cannot be negative. Okay, so I need to do 3x minus 6, and I'm going to set that equal to 0, and I'm not equal, sorry, greater than 0, because I know that my solution to this expression has to be greater than 0, just because I know it has to be a positive number because it's a length. So I'm going to add 6, and I get 3x is greater than 6, divide by 3, and x has to be greater than 2. So I know x is less than 6, but it's greater than 2, so I'm going to make my compound inequality here and say that 2 is less than x, and x is less than 6. This would be my solution. Okay? Now I wanted to look at one that we're solving for an angle as well. So I have that 57 is equal to 57. And I know that this side is congruent to itself. So I have a side, side, side inequality because two of the sides are congruent. And then I can say because 54, its opposite angle is 41 degrees, and 54 is greater than 28, its opposite angle is x plus, so it's be 20 degrees, that 41 has to be greater than x plus 20. Okay, and that's just because the opposite side is larger. So 54 is larger than 28, therefore 41 is larger than x plus 20. So I'm going to solve for x. So I subtract 20, and you get 21 is greater than x. Okay, but I want you to now look at this expression. If 21 is greater than x, then x could be any negative number. Okay, so I could say that x is negative 40. Well, negative 40 plus 20 is going to give you a negative angle measurement, which is impossible. So I need to use the fact that I have x plus 20, and I know that has to be greater than 0. Okay, it has to be greater than 0. So I'm going to solve for x. I'm going to subtract 20, and x has to be greater than negative 20. Okay, it has got to be greater than negative 20. So I know that negative 20 is less than x, which is less than 21, and that would be my total solution here. Okay, so you're including the fact that the angle measurement has to be greater than 0 as well. Okay. All right. Hopefully this helped you out just a little bit more. If you have questions over any of these, please ask tomorrow. I'm going to do my best to make sure that we have a thorough review since there's been a lot of things I haven't been here for to go over in class. Okay. Thank you for watching tonight. I appreciate it, and I'll see you tomorrow.